Hello team, my name is Sai Pratyusha Hardasu. Today I would like to discuss on the topic deep web crawling. This video provides you a small idea on why deep web crawling is used, the process of deep web crawling, its types and challenges. Let's start with introduction. What is surface web? The surface web is accessed by the browsers directly. That is, it can be accessed by search engines. For example, any HTML pages like Facebook, Wikipedia, LinkedIn, etc. Deep web. Deep web refers to the portion of World Wide Web that is not a part of surface web. Deep web data is not indexed by search engines and can only be accessed through querying. Deep web are guarded by search interfaces such as HTML forms, web services, or programmable web API. For example, personal email content or content that has password protection like online bank accounts, etc. Deep web accessing approaches. As to obtain data from the deep web is challenging and has been acknowledged as a significant gap in the coverage of search engines. There are typically two approaches to access the deep web content. The first one is virtual integration approach. It is also known as database centered discovered and forward access model. The second approach is surfacing approach. It is also known as crawl and index technique. Let's start with virtual integration. Virtual integration approach is also known as federated search, employs the data integration paradigm. In this approach, the user queries are redirected to the relevant source, which is selected by the deep web databases selection techniques through a web form based on a mediated schema. It is especially useful when it is not enough to just focus on the retrieving data from the underlying sources, but when users expect a deeper experience with the content after they found what they are looking for. Drawbacks of virtual integration approach. The virtual approach does not scale well when building a single system to seamlessly include more than a small number of domains while retaining a simple keyword querying interface. The cost of building and maintaining the mediator forms and the mappings is also high. The challenges to be addressed also include routing, that is, identifying the subset of sites that are likely to be relevant to a keyword query, and reformulation. Identifying which queries are relevant to each domain is extremely challenging. Surfacing approach. Surfacing is another common solution to search the deep web in which the crawler pre-computes the submissions for deep web forms and exhaustively indexes the response results offline as other static HTML pages. While the integration approach seems to be a promising way of constructing vertical search engines in specific domains, the surfacing approach is better at large scale and domain independent web search. We find that the web pages we surface add significant value to a search engine traffic, and their impact is especially significant in smaller and rarer domains and also queries. The surfacing approach leverages the existing search engine infrastructure, hence adopted by most of the crawlers such as Hidden Web Exposure, Hidden Web Crawler, and Mobile Web Crawler. Why deep web crawling? Deep web is rapidly growing in all major sectors like education, business, media, career, etc. So, deep web is big source of requirement in daily life. We already discussed the drawbacks of the virtual integration approach, because of which we prefer surface crawler. But the normal surface crawler cannot index the deep web data. Deep web crawling is a process of collecting data from search interfaces by issuing queries. Sending queries and receiving data are costly operations because they occupy network traffic. More importantly, many deep web data sources impose daily quota for the queries to be sent. Deep web has a large volume of web resources as well as it is dynamic in nature. So, because of this, achieving better results is a challenging issue. Deep web crawl refers to the problem of surfacing rich information behind the web search interface of diverse sites across the web. Let's discuss web crawling process. Generally speaking, the web crawling process contains 5 steps, which includes automated deep web entry points. This is nothing but discovering, locating, and estimating the deep web data sources. The next step is form modeling. It understands the HTML forms of each data source. The next step is query selection. This is nothing but selecting the appropriate queries. The selection can be done in the form of forms or frequent terms, and also sometimes random document querying. After the query selection, the next step is submitting the form. The selected query will be submitted, and the last step is crawling path learning. It is a sequence of pages that crawler must visit and the interactions required to access relevant pages. Now let's go through how some deep web crawlers work. First, hidden web exposure. The basic actions of a hidden web crawler, such as hidden web exposure, are similar of other traditional crawl. It starts with choosing the URL, retrieving the pages, extracting the links, and adding to the queue. If the extracted link are in the format of forms, it performs form analysis. In the form analysis, parse and process the form to build an internal representation. If it is not formed, then it goes to the URL selection again. If the form is not done, then performs the value assignment and submission. The value assignment and submission generates the best value assignment and submit a completed form using that assignment. Once submission is done, it goes through response analysis. In the response analysis, analyze the response page to check if the submission yielded valid search results or if there were no matches. This feedback could be used to tune the values assignments in step 2. After analysis is done, it redirects to response navigation. In the response navigation, if the response page contains hypertext links, these are followed immediately and recursively to some pre-specified depth. Note that we could as well have added the links in the responsive page to the URL queue. However, for ease of implementation, in Hidden Web Exposure, we chose to navigate the response pages immediately, and that too only up to a depth of 1. The next crawler is Hidden Web Crawler. This follows the same process as Hidden Web Exposure. It contains 3 main components: Form Analyzer, Form Processor, and Answer Analyzer. The URL list consists of URL seed generated by crawler. Crawler Manager controls the unified crawling process that takes the URL from the URL list and downloads the URL pages. Downloaded the URL pages are forwarded to the parser that displays and finds hypertext links and adds them to the URL list. The form analyzer parses and processes the form when search forms are found on websites. The label value set table values are assigned to the different form elements and submitted to the web by the form processor. Web response pages are analyzed by the answer analyzer, and this information is used as a feedback for next iteration. When the links or the response pages are found, they are added to the URL list and visited recursively. The next crawler, mobile web crawler. The middle layer is communication layer which connects to the internet and to the server side. On the server side, the interaction starts with query building database. As hidden data may consist of number of tables, forms, and other unstructured data that needs to be queried. Query building database is actually a table of values that can be used by using an adequate revisit policy. This interacts with Query Manager. Query Manager performs 2 main tasks: query generation for NoSQL Manager and response analysis. The next is storage rules and metadata. Storage rules and metadata knowledge of the internal structure, schema, and constraint of the database that can help to construct an effective query. After the query is generated, it is sent to the NoSQL Manager. NoSQL Manager for the data at local server is accessible easily and directly. So it searches and obtains the results. The next it goes to Archive Manager. The results that are obtained after querying the database by NoSQL Manager via Query Manager needs to be sent back to the site of organization of the mobile crawler. The results is finally sent to the outbox. Outbox acts as a buffer where messages stays before dispatching them out on the communication channel. The messages are sent out at such time when the conventional network traffic is low so that it does not increase the traffic load on the server. Let's discuss on some challenges of deep web crawling. The first challenge include in the step 1 of process of the crawling is to find the entries of deep web data sources from trillion surface web pages and accurately estimate their properties such as their sizes. In the second step of process, the automated recognition of proper search interfaces for accepting queries is a challenge. Selected queries can return most contents of deep web data sources with minimal network cost is the key challenge in third step. The main challenge of the fourth step is to train an agent to automatically extract the specific contents from written documents. Challenges in fifth step include create crawlers that can handle development, updates, and common technologies. Some other drawbacks also include sending queries and retrieving data or costly operations. The next one is cost to retrieve data. This is nothing but how to minimize the amount of duplicate results. How determine the best scale of sites in deep web that a crawler can review is also one of the challenge of deep web crawling. Here are the references which I have gone through. Thank you.